This sequence is about a river valley that is quite unlike anything there is in the UK. To our eyes it may look unusual, but worldwide there are thousands of river valleys with landscapes similar to this. By global standards, this is a common piece of physical geography. It's the Rakaia River on New Zealand's South Island. The source of the Rakaia, like all the other rivers around the world with a similar physical geography, is in high glaciated mountains.
What a fantastic spot! There'd probably been no hope of getting up here in the winter. We're very close to the highest peaks in the South Island, and winter's the time when the mountains get pounded by blizzards coming in from the Tasman Sea to the west. Some places recording an amazing 12,000 millimetres of precipitation a year. Today is March the 4th, getting towards the end of summer, but there's still plenty of ice left. And ice as a way of feeding rivers is very common in New Zealand. One estimate says there are 3,100 glaciers in the country.
New Zealand is still in the middle of an active mountain building period. Every year, the peaks at the head of the Rakaia Valley get 2 centimetres higher, an amazing speed in geological terms. As the land heaves upwards, the ground is constantly shaken and loosened up by earthquakes, hundreds of them every week in the mountain areas.
So, what with the high precipitation, the glaciers and the earth movements, the top end of the Rakaia River Valley is actually falling apart.
Downhill from the ice, there's no sign of the river yet, but it is there, flowing beneath the huge thicknesses of loose rock, the moraine, that the ice has ripped away from the land surface. It then seeps up from under the moraine and forms a lake. At the far end of the lake is the first sign of water on the move, the source of the Rakaia. Ice, moraine, lake, river, a typical sequence for a stream with its source in a glaciated area. In this sort of environment, a river builds up a huge supply of material to shift downstream. What with the earth tremors, ice action and relatively soft rocks, landslips can rip down the valley side at any minute. Landslips come in various shapes, sizes and designs.
What was once the top of the hillside overlooking the valley is now right here, 200 metres farther down from where it started. It's come to rest in the shape of a triangle known as a fan, and the material the fan's made of is called scree. It's hard to say exactly when the landslide happened. It could be maybe as recently as 30 years ago, but what is certain is that it's happening the whole time throughout the river basin, producing huge amounts of material that will eventually slide into the river.
In river valleys in mountain areas in the temperate latitudes, there's one particular force that's especially good at loosening up the landscape. It's called freeze-thaw action. The ideal environment for this process is an area where the rocks are broken by small cracks, just as they are in the upper section of the Rakaia Valley. The next requirement is frequent rain, again just like the Rakaia. The cracks fill up with rainwater. Then, if the temperature drops below 0, the water starts to freeze. Ice, though, needs more space than the water it came from, so it tries to expand. The pressure is around 1,000 kilograms on every square centimetre. Too much for an average Rakaia rock. In the Rakaia Valley, the rates at which this and other kinds of erosion are happening are among the highest in the world. In places, the sediment clogging the valley can be 100 metres deep.
The result is something that's a bit unusual for a river valley. We're still in the upper mountain section of the Rakaia River, but the bed is incredibly wide, with a lot more sediment than water.
And if you're wondering how such a river could possibly have done all this, it's a good question. The answer is the river didn't, not on its own. Around 15,000 years ago, just after New Zealand's Ice Age, the Rakaia Valley was considerably deeper than it is now. Every summer came huge floods of meltwater from the ice caps, which still covered the mountains upstream. Sediment piled into the river from landslides and scree on the exposed valley sides, raising and widening the riverbed. The floods had transformed the look of the valley, a look that survives today. There are still occasions when the Rakaia surges forward and fills its valley, but more often than not, the present river flows on a bed that was made long ago. Rivers like this, which flow out of glaciated highlands, are known as braided. By the time the Rakaia enters its lowland section, the braided pattern is very strong indeed. 5 kilometres from the sea, the river bed is a massive 2 kilometres wide. To us, this looks like the mud you'd find in an estuary. Not so.
There's one terrific advantage with a braided river valley of this size. The enormous width of sediment that's been laid down acts as a kind of safety valve against flooding. Even when the river's at its maximum flow, there's plenty of space to cope with the extra water. The river expands to the edge of the sediment, but stops short of the surrounding farmland. Another thing about the Rakaia is that with this kind of sediment all the way down the valley, nobody has ever bothered to farm it. So the land on either side of the river is untouched, completely natural, and able to cope with the river when it's in flood. Interestingly enough, none of those things apply to another river we're going to be looking at in this series, the Mississippi. Meanwhile, just before the Rakaia enters the sea, I've got about another kilometre to go to get to the other side. This is really hard work. Even though it's the end of summer, the ground up on this moorland is still pretty soggy. My surroundings might look pretty anonymous, but the spot where I'm standing now is actually the source for the mighty River Severn, the longest river in Britain.
Almost 80% of UK rivers start in soggy moorland like this. These are the Plynlimmon Hills in mid-Wales, 740 metres above sea level. A wild, desolate area which is largely uninhabited. The west coast is just 20 kilometres away, so this part of the country gets the full force of depressions coming in from the Atlantic. It receives over 2,500 millimetres of rainfall every year, making it one of the wettest parts of Britain. The ground acts like a huge sponge hanging onto a large amount of the rain. The excess runs off. Trickles become rivulets, which then form a stream.
Here it is, the River Severn. It doesn't look like much now, but it's only just got started.
Fed by dozens of rivulets, the stream swiftly grows in size and power, cutting down through the landscape to form a V-shaped valley. And it's getting bigger all the time. It's also fast-flowing, which means it has a high carrying capacity, the ability to carry material that's been stripped from the land.
Some of the material carried by the river is dissolved in the water. Some is suspended in the flow, and some like this rock, is dragged along the bed by a mixture of flow rate and gravity. All this load is the ammunition required to erode the landscape.
Even at the end of the summer, the river is already flowing at 1,000 litres per second. It makes a dramatic sight as it plunges over this waterfall, which is called the Severn Breaks Its Neck. There are several ways in which waterfalls are formed. The most common one is due to a difference in rock type. Where a strong band of rock lies on top of a weak band, the water falling will erode the underlying weaker rocks. After a while, the inevitable happens. Over time, the waterfall cuts back. Eventually, a gorge is formed. After the waterfall, the Severn's gradient soon flattens out, and it starts winding its way through agricultural land. In flat areas, rivers wander about, forming loops of all shapes and sizes on the valley floor. These are known as meanders. Although they all look different from above, they share the same common features.
As you can see, on the outside of the bend, where the water's moving faster, it's cutting into the landscape, forming that long cliff. But here, on the inside of the bend, where the water's moving much slower, all this stuff is being deposited.
The erosion has left a very small neck on the meander. If we strip the trees away and look at it from above, it's easy to see what will happen next. The fast-moving stream will continue to erode the banks on the outside of the bends. It also erodes the area around the meander's neck. Eventually, the river breaks through, cutting off the meander and forming an oxbow lake. After Shrewsbury, the river drops through the Ironbridge Gorge and swings south. By now, the Severn is flowing at over 60,000 litres of water a second, and although the river's mouth is still over 100 kilometres away, it's only 30 metres above sea level. Surrounded by flat land, floods are a significant threat. In November 2000, heavy rains caused some of the worst flooding since records began. Many rivers, including the Severn, burst their banks, causing widespread disruption and damage.
In the past, people have been quite clever about avoiding these disasters. This is Worcester, and the cathedral and the old town are much higher than the rest of the city. That's because they've been built on a river terrace, out of reach of the floodwaters. Since then, the town has grown, and there's been nowhere else to go except down onto the floodplain closer to the river. These Victorian houses risk getting flooded every winter.
Building on a floodplain also changes the way the land works, a fact that isn't always understood. When rain falls on open countryside, the ground acts as a big sponge, soaking up a lot of the water. But when the land is built on, the paving and tarmac stop water seeping into the soil. Instead of the water ending up in the soil, it's swiftly drained through pipes into the river. That's okay in normal conditions, but when it's very wet, the extra runoff can tip the balance, causing a river to flood. The situation is really serious, and at the moment, no one seems to have an answer. South of Gloucester, the risk of flooding decreases rapidly because the river starts to widen and it quickly develops into an estuary.
It's one of the biggest estuaries in the UK. At this point, it's already 2 kilometres wide, and south of the narrow point where they built the bridge, it's even wider still. The river here is tidal and has the second largest tidal range in the world.
The difference between the high water mark and the low water mark can be as much as 15 meters. And when the tide is out, huge expanses of mudflats are revealed. Many rivers in the UK, like the Thames, the Humber and the Forth, end in a wide estuary, and they all present the same problem. You need a long bridge to get from one side to the other. Here on the Severn, there isn't just one bridge, but two that carry traffic between England and Wales. South of the crossings, the river becomes much deeper, which means ships can come in. This has attracted industry to the cheap land around the estuary, and the shoreline is chock-a-block with factories and dock facilities.
I'm just surrounded by industry. There's a smelting works over there, several chemical plants over there, an LPG and oil terminal down there, and just over here is a container terminal for import and export to all over the world.
500,000 cars pass through the port each year, and the £27 million refit of the neighbouring Portbury docks should ensure that traffic through the area continues to grow. By the time it reaches its mouth, the Severn is 13 kilometres wide. The river looks like the sea. Having started as a trickle in the Plinlimmon Hills, it has run 350 kilometres. And by the time it reaches the sea, it carries over 9 billion litres a day. Quite a transformation. In the summer of 1993, the Mississippi, one of the most heavily engineered rivers in the world, burst its control banks in one of the most devastating floods to hit the USA. This event brought to a head a question that has been smouldering for a very long time. Can big rivers like the Mississippi ever be completely tamed, or will nature always, somehow, take its course? The Mississippi is over 3,000 kilometres long, draining half of the United States. It's the major river artery of America. 300 years ago, before Europeans arrived, the landscape in the valley was a wetland measuring 100 kilometres from east to west, across which the river wandered at random. During periods of really heavy rain, the river burst its banks, turning the floodplain into a lake. When the rain stopped, the river would often return to a completely different route from the one it had taken before. This was a nightmare for shipping. The average paddle steamer only lasted 18 months before crashing. Without a reliable shipping channel, the transport of farm and factory products was chaotic. The valley's economy in dire straits. Something had to be done. It was the Army engineers who took on the huge task. Their first move was to build what are known as wing dikes out into the river. Built from tough stone, they trapped large amounts of the river's sediment, forming new land, which narrowed the channel down. What happened is what the engineers had predicted. Forced into a narrower width, the river flowed faster and eroded a deeper channel. A much better bet for shipping. But this didn't solve the flooding problem. Every spring, as the winter snows melted, the river did what it had always done. If agriculture, cities and industries were to grow successfully next to the river, another idea was needed. This time, what the engineers did was literally wall the river in. These walls, known as levees, were built along the whole length of the river, eventually offering better protection to riverside developments. But as the population grew, the engineers came under huge pressure to make sure that flooding would never ever again be a threat to people and property. At that point, they really went for it. First, control dams were built to hold back floodwater and reduce pressure on the levees. Second, they changed the map of the valley. Shortcuts were blasted through the numerous meanders. Water was speeded more smoothly downstream. The natural course of the river dried up. By the time they'd finished, the Mississippi was 250 kilometers shorter. Third and finally, the river banks were stabilized with matrices of concrete slabs. It's taken 100 years and £7 billion to change the whole look of the Mississippi River landscape. Then, in the late spring of 1993, the weather over the Mississippi Basin went mad. The border between the warm air from the Gulf of Mexico and cold air from the Arctic got stuck 2,000 kilometers farther south than normal. Along this crucial junction, it rained for weeks on end. The result was a massive increase in the volume of water in the river. Water that in the river's natural state would have spread sideways was hemmed in, trapped between the levees, leading to a frightening build-up in pressure. The river didn't like it. In the end, the levees gave up under the sheer weight of water. Having more or less protected the riverside areas from the Mississippi's average behavior, the engineering could not ultimately cope with nature at its most extreme. The lesson from 1993 is that the Mississippi will probably do the same thing again. The threat of flooding will not go away. But how could anybody ever say, "You can't build here"?